Good day everyone. For the part 2 of our video on the analysis of uh, square spread footing. Okay? So for the number 3 question naman, ang pinapahanap sa atin is the punching shear. Okay? So lagay ko muna doon. Ayan. For punching shear. Ayan. Let's say this is our footing kanina, di ba? Okay, so ang sabi ng code that the failure will occur. So ganito yung itsura ng failure daw kapag punching shear. Okay? So kumbaga para siyang square lang din, okay? So hahanapin natin mamaya o sasabihin ko mamaya kung ano yung distance nito from the face of the column. So as you can imagine, okay? So kung meron daw tayong pababa na force from the column and then may babalik na stress from the or the overburden stress or overburden pressure sa baba na QU, okay? So magkakaroon tayo ng gantong failure. Okay, itong red na to. So kapag dinrawing natin sa isometric yan, so wait lang. So ito yung mangyayaring So ito yung mangyayaring failure. So sa isometric view, wait lang. Ayan. Sabi na hindi ko na alam sabihin ka. So base sa isometric view, so kung naiintindihan nyo man, sana naiintindihan nyo, that the column, okay, so ang effect ng column sa ating footing is that parang sinuntok niya kumbaga. Okay? Sinuntok niya at nabutas siya doon. Okay? So ito yung part, itong red part na to, ito yung part na nabutas. Ito yung critical section, okay? Kaya kinulayan ko din siyang red. Okay? So ibig sabihin nun, yung force na galing sa ating column will push the footing downwards. But then again, due to the ultimate soil bearing pressure, so meron din siyang pataas na force which is QU. Di ba? So therefore, magka-counteract kaya meron tayong punching shear na nangyari. Okay? So since this is pataas and this is bababa, yung part na to, itong cross section na to, is dinala nung ating column papunta dun sa baba, and then itong part ng taas na to is itutulak nung soil bearing natin pataas. Okay? So to get the punching shear stress, again, since shear yung usapan natin or shear stress, so that is VU or the shearing area all over the area. But ano nga ba yung VU natin dyan? Okay? So we can select from these two members to use. Okay? Kasi sa two members na to, when we analyze them or get our shearing force, equal lang yan. Okay? By the law of equilibrium. So for this member, okay, itong part ng member na to will have a VU that is upwards. Okay? If we have this member naman sa mas maliit na part, edi downward siya. Kumbaga dito part na to, okay, sa member na to, we'll have our shearing that is upward, and here we'll have a shearing that is downward. Okay? Kumbaga kanina parang sa yung sa last video is yung left part will push will slide down, okay? And then for the right part will slide up. Okay? Parang ganun lang din to. Okay? When we select a member or a section of consideration. Okay? So again, when we solve for the shearing stress, since wala naman sinabing ultimate, okay? So ang sinasolve natin for this problem is nominal. Okay? So we divide or times our area with the reduction factor or phi. Okay? And then for the area, ano yung area niyan? Okay? So since parang rectangle lang siya, based sa CP, this is called BOD. Okay? Or yung BO shall be the perimeter of the critical section. Okay? So ano nga ba yung critical section nitong ating punching shear stress na to. Okay? So when we get the critical section, kasi ayon sa NSCP, the critical section will be, okay, so from the face of the column, ang ating critical section daw will be D/2. Okay? Around our column. So again, so therefore, dito sa part na to, D/2 lang din yan. Kuha? So for this part na din na to, okay? So all around our column or column or footing, okay? D/2. Kuha? Kuha yan. Okay? From the face of the column. Next naman. Let's say we have this di ba? We have this length of this part na to. Okay, which is the column width or column dimension. Tama ba? C. Therefore, when we get this length right here, okay, kumbaga parang ano lang siya, or this part right here, equal lang naman yan, since square. Part right here, that is C, di ba? Therefore, itong total length na to will just be C plus D. Tama? Kasi we have D/2 plus D/2, that is a 1D or isang D, plus C, that is C plus D. So therefore pala, itong perimeter ng critical section na yan will be 4 times C plus D. Okay? So yun lang yan. Then, okay? Kuha. So yan yung sa critical section ng ating punching shear. Okay? So now, how do you get the shearing force? So to get the shearing force, we have to consider a member. Okay? Any member dyan sa dalawang yan, we can use. Okay? Equal lang yan. So for this problem, ito gagamitin ko. Then, siguro explain ko na rin kung paano kunin tong shearing force nitong babang to. Itong nabutasan dito. Okay? Ano nga ba yung shearing force dyan? Or yung shearing force ito. And then shearing area will be this. Tama ba? Kung magkakaroon, yung magkakaroon ng shear will be here. And then ito. Tama ba? Kasi may kiskisan dyan part. Okay? So, yung BOD yan. Ito yung critical section. So, yung perimeter lang yung kakailanganan natin for BO. And then, of course, kailangan natin yung effective depth. Okay? So, to solve the shearing force, again, ito. Considering this cross-section here, right here. Okay? So shear force or force is just equal to stress times area. Okay? So, ang stress natin dito will be the ultimate bearing stress, which is QU. Okay? Times the area. So, ang area natin is, since squared footing lang yan, okay? So, therefore, that shall be equal to B squared. Okay? So, B times B lang yan. Okay? Itong cross-section na to, that is B plus B. B times B. So, B squared. But, in this member or in this cross-section, meron tayong butas. So, hindi B squared ang buong area ng shearing na yan. Okay? So, to get the area of this whole segment, edi minus natin siya ng butas. Which is, ano yan? Squared lang din yan, di ba? Square. Kumbaga, ito, C plus D to. Ito, C plus D lang din yan. So, therefore, that is only C plus D squared. Okay? So, yan yung magiging shearing area natin. Or area. Okay? So, VU shall be equal to QU. So, ano bang QU natin last time? So, QU, that is 0.213, I think. Okay, 0.213. We have 0.213 times B squared. So, B natin, the 3 by 3. So, 3 squared minus the column dimension. So, that is given as 400 millimeters. So, convert ko lang muna to 0.4. Plus the effective depth. Okay, ayan na. So, ano yung gagamitin natin na effective depth for this punching shear? So, for NSCP 2015, it states that the effective depth na kukunin natin for punching shear will be the average effective depth. Okay? So, ibig sabihin lang pala nun, the effective depth shall be the average of the two. So the effective depth of the top bar plus the effective depth of the bottom bar all over 2, that is our effective depth for punching shear pa lang yan, ha. Okay? So to solve dt, okay, or the effective depth sa top bars. So meron tayong effective depth sa top bars, which is this, tama. Solve natin on the first part. So 495 mm. And then for the bottom bars, okay. So bottom bars, wait lang. Move ko lang itong ano. And then here. Okay. So for bottom bars, that is yung 600 na total height minus concrete cover, that is 75. So 600 minus 75 minus ilan yan? So considering bottom bars, itong part na to, ilan yan? Kalahati ng diameter ng calculate ko. Ayan. So 600 minus concrete cover minus kalahati ng ating bottom bar. So 0.5 of 20. That is point. So we have 515 millimeters. Okay. So to get the effective depth of the punching shear, the average nyo lang yan. Okay. You have 495 plus 515 divided by 2, that is 505 millimeters. Okay. So we are going to use the effective depth for this problem is 0.505 mm. So to be consistent, gawin natin siyang in meters. Okay. So ano ba yung 213? Megapascal siya. So this should be. Okay. Gawin na lang ito mm lahat. Para Newton mo na siya. Okay. Well, let's say ito na lang yung baguhin ko. Times 10 raised to. VU is equal to 0.213 times 10 raised to 6. So, kilonewton ilalabas dyan. Okay. So, solving 0.213 times 10 raised to 6. Kung mas mabilis kayo mag-solve sa akin, okay lang. Iunahan nyo na ako dito. Nabagal ako magpindot eh. 0.4 plus 0.505 squared. So, VU is equal to 1,000 para maging kilonewton. Okay, so ang VU natin shall be equal to 1742.5 let's say 55 kilonewton. Okay, VU pa lang yan. Hindi pa lang shearing stress. Okay? So therefore, to get the shearing stress, there is VU 1742.55. Sabihin natin newtons lang. Okay? Para mas madali siguro. Para mag-ibang megapascal. Let's say times 10 raised to 3. Binalik ko lang eh. So, ayan. So again, the reduction factor for shearing stress is thus only 0.75. Okay, and then BOD, na-discuss ko na siya sa inyo. Ito yun. Okay, perimeter. That is 4 times C. That is 0, sabihin, since megapascal yung una, then this 400 plus the effective depth, that is 505. So, ito na yung perimeter or BOD. And then we have to multiply it ulit sa effective depth. Okay. So, solve natin yung shearing stress. That is 1742.55 times 10 raised to 3. 0.75 times 4 times 400 plus 505 times 505. Okay? Ang sagot natin will be equal to 1.27 megapascal. So this will be our answer for question number 3. About 2. Okay, so this is our answer for question number 3. The punching shear stress sa ating footing. So may nakalimutan pala ako discuss. Okay? So iti-testing din natin kung gumagana siya from this cross section. Okay, so kapag yan yung ginamit nating member. Okay? Ayan. I-prove ko lang na tama na equilibrium yan. Okay? So again, dahil sa ground, meron tayong ibabalik na force that is QU. Okay? So to get the shearing force sa part na to, okay, that is VU. Pangit ang sulat ko, sorry. So to solve VU or the shearing force that is downward, so VU is equal to stress times area ulit. But QU and then times yung area natin. Well, let's say we have this PU muna. Okay? So we have na dati itong PU na to. So PU minus, okay, may force na dati dito pala naka-applied. So that yung PU natin. Minus QU times yung area nito. Which is just, alam nyo na siguro, that is C plus D. Okay? Squared. So yan yung magiging area niyan, part na yan. Tama. Okay, so VU, so PU natin from this problem was 1920. So 1920 times 10 raised to 3 or 1000 minus QU, that is 213. C, that is 400 plus 505 millimeters squared. Okay, so VU natin should be equal to that too. Okay, so 1920 times 1000 minus 0.213 times 400 plus 505 squared. Okay. Yeah, let's double check the problem. 1920 to 1000 to 13. Ito naman. 400 plus 505. Okay, so okay, double check ko lang yung mga binigay na given. So sa part na to, mahirap na. Times 10 raised to 3 na lang. Times 3 squared minus 0.4 plus 0.505 squared all over, wala na. 1, sabihin natin 1 na lang. 142.55. Okay, so may unting discrepancy. That's alright. Okay, that should be equal, guys. Wala. Okay, dapat equal yan, ha. Okay, so may unting discrepancy. But itong part na to kasi, medyo kulang tayo dyan. So when we convert that into, since megapascal yan, into kilopascal, it should be 213.33. Yan yung kompleto. So when we solve that as 213.33, ang magiging sagot natin will be 174.5.25. But it's okay, that's okay. Okay? You can use megapascal or kilopascal, but pag kinompleto nyo yun, convert nyo, store nyo na lang. Okay? So dito rin, if we use 213.33 kilopascal instead of megapascal, the answer will be the same. Okay, so 1745.25. That's so we have proven that from this you can use any cross section that you want from these two or any member from this punching shear. Okay, so yun ang pinurove ko. So let's proceed to the question number 4. Okay. Ano yung question 4 na yun? That is, tanggalin ko lang ito. Okay, go dito. Okay. So, that is for bending moment or failure, or rather ultimate bending. Okay. Ultimate. Okay, so we are talking about ultimate bending moment. Naririnig yun. Ayan. Ultimate bending moment. Okay, so again, let's consider our problem. Okay. Yung top view ng ating problem. So for footing that is supporting a concrete, okay, like concrete wall or concrete column, the critical section here will be at the face of the column na mismo. Okay, so that will be the critical section, either here or here. Okay? So dyan magkakaroon ng critical section. So paano natin imagine yun? So let's draw the view. So i-pause ko para okay, let's say this is our footing. Okay, so again we have a force from our column that is acting downward, and then again from our ground nagre-react yan ng pabalik, which is yung tinatawag nating QU. Okay, so ang assumption kasi dito, yung ating footing will act as a beam that is fixed on the our critical section. Di ba nga, ito yung critical section natin. Okay? So, kumbaga, sabi niya, itong footing dan natin will act as a beam that is fixed on this critical section. So, ganun daw yung assumption natin. So, from this, we can imagine that our footing is like a cantilever beam na tinutulak nung itong QU na to pa ganito. Okay? So, exaggerated na yan. Okay, bending nga di ba? So, magkakaroon ng bending sa part na ganyan. Okay? Ang ating footing will act like a cantilever beam kasi fixed siya dun sa critical section. Ngayon, yung bending moment na mangyayari dyan, yun yung ating i-solve. Okay? Okay, so yan. So, first is we have to consider a cross section again, or a kumbaga a member. So, ito yung consider ko. Okay, so drawing natin yung kanyang isometric view. Kumbaga. So, again, sa critical section, fix siya, di ba? Okay, and then ito yung mismong footing na. Let's say, so, pangit ng drawing ko, guys. Pagtiisan nyo na lang. Kumbaga, para siyang mahabang beam eh. Okay? Para siyang mahabang beam na lang. And then, ito yung part na critical section. So, fixed daw yung part na yan. Okay? So, fixed. So, again, meron tayong QU. Ito nga yung ito yung magkukos ng bending along this cantilevered beam natin na kumbaga. Okay? So, QU. So, from TOS or strema, di ba nga, when we get the moment along a beam, di ba kinukuha natin yung kanyang resultant or the magnitude? Since QU kasi, that is uniformly distributed kasi ang column natin is acting concentrically. So, yung QU dyan, or yung binabalik ng ating ground, is uniformly distributed sa footing natin. So, therefore pala, kukunin natin yung magnitude niya. Okay? So, tawagin natin siyang R. Di ba nga, sa gitna naka-act yan? Okay? So, ganun lang pala, we consider the footing as a cantilevered beam. Okay? So, to get the moment along that cantilevered beam, okay? So, force times the moment arm or the lever arm. Tama ba? So, therefore, ganun lang pala kadali to get the ultimate moment. So, F natin, ang force natin dyan, acting on that member is, again, QU. So, stress times area. So, ano yung magiging area natin sa member na yan? Okay? So, we have, so this is B, di ba? So, that is B times, ano yung times natin dyan? Yung length nito. Ano nga ba yung length niyan? Or yung length na to? B times L lang, di ba? So, yung length na yan, since, okay, paano ba? Since, this is, from this, dami ko na sinasabi, no? So, from this side, sabihin natin, this will be, kalahati nung ating B. So, B over 2. And then, itong part na to is kalahati nung column. That is C over 2. Okay, so to get this part right here, pala, so yung kalahati ng B over 2, kalahati ng B over 2. Ito yung B over 2 mismo, minus C over 2 lang. Ito yung makukuha natin na cross-section. Tama ba? So, B over 2 minus C over 2. Okay, but to simplify, that is, B minus C over 2 na lang. Okay? So, yan yung magiging length natin. So, naintindihan ba? So, pwede nyong i-replay naman kung hindi nyo naintindihan. Okay? So, B over 2, B minus C over 2. That is the length of our cantilevered beam. Okay? So, B minus C all over 2. So, ito na yung stress times area. So, ito na magiging, kumbaga, force natin. Okay? Ito na yung magiging R or force. And then to get the moment arm or the lever arm, di ba nga, since this is rectangular na parang distributed load, rectangular beam to, so kukunin natin lang pala from the analysis of shear and moment sa beams, di ba? Yung load na QU na yan, kukunin natin yung sa rectangular nito is kalahati. Tama? Okay? So, kalahati nung length na yan. That will be our moment arm from this point. Okay? So, kalahati ng, that is 1/2 of, ano yung kalahati? Ito yung kalahati. Kalahati ng B minus C all over 2. Okay? So, ito na yung ating lever arm. Okay? So, again, imagine niyo lagi yan na yung QU is a uniformly distributed na pataas. Okay? So, therefore, we can solve for the ultimate moment that is, okay, to be consistent, sabihin kong 213.33 times our B, that is 3. Tama ba? And then, 3 minus 0.4 for the dimension of the column, all over 2 times 1/2 of 3 minus 0.4 all over 2. So, ang bending moment natin will be equal to 540.79 kilonewton meter. So, this will be our bending moment or our ultimate bending